every weather change that is occurring is because of the movement of the air around the Earth's atmosphere. The heating of the Earth is mainly because of the heat that is absorbed by the sun's radiation, which is entering into the Earth's atmosphere. Now, which region receives how much amount of rain, whether they are going to receive the rain, whether they are not going to receive the rain, all that depends on the air mass, that is the flow of the air. Hello everyone, a warm welcome to today's session on Environmental Studies for second semester BCom. I am Dr. Divya, Environmental Studies faculty, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. So we shall continue with studying Unit 3, that is Natural Resources, Renewable and Non-Renewable Resources. So in today's session, let us learn about the topics under Renewable and Non-Renewable Resources, about atmospheric circulation and how this atmospheric circulation heats the earth, and about the airflow, all that we shall study. So let's know what the definition of atmospheric circulation is. So atmospheric circulation is nothing but the pattern of air movement around the Earth's atmosphere. So how exactly the air moves? What is the pattern of the movement of the air or the flow of the air in the Earth's atmosphere or around the Earth? That is nothing but atmospheric circulation. So this is the definition. So next, moving further, let us learn what are the factors for atmospheric circulation. So atmospheric circulation occurs because of many factors, and one important factor among these are the sun. That is because the sun heats the earth more at the equator than the pole. So we all know that our earth is divided into the equator, wherein above the equator we have the tropical region, the temperate region, and then we have the North Pole and the South Pole, right? So this is how the earth is divided. So here one of the factors, like how exactly, what is the reason for atmospheric circulation is, when compared to the poles, that is the North Pole and the South Pole, the movement of air or the circulation of air around the Earth's atmosphere is more in the tropical regions or in the equator region. So it is more in the equator region. So that is one of the factors. And atmospheric circulation also depends on the spin of the earth. So how the earth is rotating, what is the speed of the earth's rotation? So based on spin of the earth also, the circulation of the air depends. So two important factors, one is the sun, heating of the sun. So one reason for atmospheric circulation is the heating of the sun. Because the heating of the sun is more at the equator, the sun's rays are received by the equator region of the earth more when compared to the polar region. That is why atmospheric circulation is more in the equator region than the polar region, because more amount of sunlight is received by the equator region, therefore that particular region gets heated more when compared to the polar and the, that is why, right, the polar regions, that is the North Pole and the South Pole, they are made up of ice caps, because the sun energy that they receive is, or the heat that they receive from the sun is very, very minimal or negligible. Next important factor is the rotation of the earth or the spin of the earth. So next, let's study about, since we know that one of the major factors for atmospheric circulation is the heating of the earth by the sun, right? So heating of earth and circulation of the air, how are they interrelated to one another? Let us look into, because for circulation of air or for atmospheric circulation, the sun's heat plays a major role, wherein I told you the equator receives more amount of sun's heat when compared to the North Pole and the South Pole. Therefore, the atmospheric circulation or the flow of air is more in the equator when compared to the North Pole and South Pole. So let's study about this in detail, that how exactly it occurs. So solar radiation, that is the rays or the radiations from the sun, it reaches the earth, and once, how does it reaches the earth? It reaches the earth, then it passes through the atmosphere, and it is either absorbed or reflected by the atmosphere and the earth's surface. So we all know that a part of the sun's energy or heat that is received by the earth, some part will be absorbed by the earth's atmosphere and some gets reflected back, right, out of the atmosphere. So that is what happens here. So when solar radiation reaches the earth, it passes through the atmosphere layer of the earth. So in previous classes we have learned the earth is made up of 3 different layers: the atmosphere, the hydrosphere, the lithosphere and all that, right? So the solar radiation first passes through the atmosphere, and once it passes through the atmosphere, either a part of it gets absorbed by the earth and the remaining a few amount of the heat gets reflected back to the atmosphere itself. So that is how the solar radiation reaches and passes through the atmosphere. So most of this absorption, so most of the solar radiation that is absorbed happens on the earth's surface itself, and therefore this whatever heat is absorbed by the earth's surface, that will cause heating of the earth, and therefore it will increase the temperature of both the lithosphere and the hydrosphere. So that is why atmosphere, lithosphere and hydrosphere, all these three are interconnected to one another. So what did we understand? The sun's rays will enter into the earth's atmosphere. It will have a lot of heat energy in it, right? In that, some part of the heat is absorbed by the earth and some part of the heat is reflected back to the atmosphere. That heat that is absorbed by the earth actually increases the temperature of the land and the water that is present in the earth. So now we know that the surface of the earth absorbs the heat. So sunlight absorbed by the earth's surface is re-radiated as heat, and this re-radiated heat will warm up the atmosphere from the bottom up. So here what did we know? That the sun's radiation that enters into the earth, it will be absorbed. A part of the heat will be absorbed by the land, that is the earth's surface, that is by the water and the land that is there in the earth, right? And some amount of heat, I told you, it is reflected back. So this reflected back heat which is reflected back to the atmosphere, it increases the temperature of the atmosphere. So therefore the heat that is absorbed, the solar radiation that is absorbed by the earth, increases the earth's surface temperature. The solar radiation that is given back to the atmosphere increases the atmospheric temperature. So this heat which is absorbed and which is reflected or which is re-radiated back by the greenhouse gases in the atmosphere, it results in greenhouse effect. So we all know about greenhouse effect. We have also learned in the previous sessions wherein we understood that there are some gases such as the carbon dioxide, methane and all that is there in the atmosphere that actually increases the earth's temperature because it helps in absorbing most of the sun's energy or the heat that is entering into the earth's atmosphere. So therefore, this is nothing but global warming. So therefore, the heating of the earth is mainly because of the heat that is absorbed by the sun's radiation which is entering into the earth's atmosphere. So that is why circulation of air and heating of earth is very, very important. So which region absorbs maximum amount of heat? It is the equator region. Therefore, circulation of air in the equator region is more when compared to that of the polar region. So that is about heating of earth and circulation of air. So now there is variation in the every time it is not the same amount of solar radiation that will be absorbed, because I told you the heating of the earth also depends on the spin of the earth, right, or the rotation of the earth. So therefore variation in the amount of solar radiation that is absorbed and the amount of heat re-radiating from the earth's land as well as the ocean, that is from the lithosphere and the hydrosphere, it will actually result in temperature differences in the air over different types of terrain. So in different types of terrains or regions of the earth, the temperature variation occurs because not all regions receives equal. The absorption of heat is not the same and the amount of heat that is re-radiated is also not the same. So therefore, the circulation of air in different terrains tend to vary because of this particular reason. Say for example, let us consider the sea breezes. So why does the sea breeze occurs? Why does the circulation of air in the sea occur? So sea breezes occur because land heats up. Why land heats up? Because whatever solar radiation is coming into the Earth's atmosphere, some amount is heat received by the land, right? So the land will heat up and it will cool down faster than the water. So that land is warmer during the day and breezes flow from the sea inland, but the ocean is warmer than the land at night. So that is the reason. So the wind blows from the land to the sea. So wind always blows from the land to the sea. So here the circulation of air is from the land to the sea. What is the reason? The reason behind that is when the land absorbs, that is the land near the oceans or the seas, when it absorbs amount of heat, what happens? That heat will actually heat up the land, but in turn it will cool down the water sources that is there, that is it will cool down the sea. So therefore during day the land will be warmer and during night the seas are warmer when compared to that of land, because usually the wind that is there, it actually blows from the land to the sea. So therefore the absorption of the heat during the day by the land results in the blowing of the wind from the land to the sea, which makes the land warmer during the day and the sea warmer during the night. So that is why it actually occurs. So this is one of the examples how actually the terrain, the changes, like here the terrain, say we have taken two terrains here, one is land and one is sea. Amount of heat absorbed by both is different. So based on what amount of heat they absorbed, at what time of the day they absorb that particular heat, all that will bring a alteration in the flow of the air or the circulation of the air. So that is why those two factors which I told earlier, that is the sun's radiation as well as the spinning of the earth, both of these also will decide how the air has to circulate, or the circulation of the air will be decided by those two factors. Next, atmospheric circulation transports heat over the surface of the earth, and when this heat is transported over the surface of the earth, it will affect the water cycle, because what happens when heat is circulating, when there is too much of heat circulating in the earth, evaporation of the water will occur, right? So when the water evaporates, what it will escape into the atmosphere, there it will start to form the clouds, and that clouds will condense and it will come down as rain, which is nothing but precipitation. So here atmospheric circulation, it will transport heat over the surface of the earth. This heat that is there, it will act on the water cycle. Therefore, the water that is present in the water bodies such as the lakes, ponds, rivers, oceans and all that, it will start to evaporate slowly. They will evaporate and then they will enter into the atmosphere and they will form clouds, and these clouds will come down as precipitation, that is in the form of rain, snowfall, fog, mist, etc. So the movement of air mass is the one that actually brings us daily weather. So our daily weather, every weather change that is occurring is because of the movement of the air around the Earth's atmosphere. That actually decides, because movement of the air depends on the amount of heat that is absorbed by the Earth's atmosphere. And this movement of air, because for rain to occur, the movement of air is also very, very important. We know about it, right? It is the one that actually decides the weather, and also it decides the long-term pattern in circulation, decides the regional climate and the ecosystem. So variation in the regional climate, variation in the climate of the ecosystem and the daily weather, all that depends on how the air moves. So why? Because first, the atmospheric circulation, it actually transports the heat. It helps in the movement of the heat, or it helps in the circulation of the heat to the earth's surface. Therefore, it will evaporate the water that is present in the water bodies. These evaporated vapors that are there, they will form clouds and they will come down as rain. Now, which region receives how much amount of rain, whether they are going to receive the rain, whether they are not going to receive the rain, all that depends on the air mass, that is the flow of the air. So, surface ocean current patterns usually result from the wind pushing on the surface of water. So, here we have seen ocean currents, right? The ocean currents tend to vary throughout the day. Sometimes it is calm, sometimes heavy waves are seen, all that, right? Why exactly such variations in the ocean currents occur? So, this is also because of the circulation of the air, wherein the wind will push the surface water. So, how much air is circulating on the surface water will decide the wave of the ocean or the surface ocean current, and these currents also transport heat across the globe. So that is how, because of the water also, the heat gets circulated around the globe. So therefore, at the end of the day, two factors are very important here. One is spinning of the earth and the other one is the absorption and the re-emission of the heat from the earth are two important factors that actually helps in heating of the earth and therefore the circulation of the air. And heating of earth and circulation of air goes hand in hand because it is the circulation of the air that actually distributes the heat on the earth and therefore decides in which water body evaporation has to take place, where clouds has to form, and this air circulation itself will carry the clouds, deciding where exactly the rains will come. So all that. So therefore the entire weather climate of the earth depends on the heating of the earth and the circulation of the air itself. So changes in the amount and distribution of heat in the earth system due to an enhanced greenhouse effect from human activities is altering the atmospheric and ocean circulation pattern. Why? Because normally what happens if there is less amount of pollution, that is less amount of greenhouse gases in the atmosphere, how much amount of heat should be absorbed, how much amount of heat should be given back, all that will be a natural process. Now, because of we human beings causing a lot of pollution, that especially air pollution, wherein we are filling the air with carbon dioxide and other greenhouse gases, it is causing a change in the pattern or the amount of heat that is being absorbed and the amount of heat that is being given out. So this actually causes a great variation in the atmospheric as well as the ocean circulation pattern, and in turn it also therefore alters or affects the environment or the climate around the globe. Because what happens at that particular season, somewhere they might have to receive a rain, they will not receive the rain, other region might receive the rain. So variations in the climate pattern will occur mainly because of the human intervention, especially because of the increase in the greenhouse gases, which is causing excess of heating of the earth or which is causing global warming. So therefore, the correct circulation of the air and the heating of the earth is very important if a normal climatic or environmental condition has to be maintained in the earth. So this is about heating of earth and circulation of air. So next let's study about air mass. So what is this air mass? So air mass is defined as the large mass of air whose physical features such as moisture, temperature, the lapse rate and the content are approximately uniform horizontally for hundreds of kilometers. So for hundreds of kilometers, the moisture content in the air, the temperature in the air, the rate of flow of the air, all that should be equal. So that is called as air mass. So we know about air mass. Let us understand how exactly the air mass formation occurs. So air masses are formed when air is present to the surface over an extended period. So when air is present on the surface of the earth over an extended period, so if this air has to circulate over the surface of the earth over an extended period, what is important? The heating of the earth is important. That too a normal heating of the earth, not because of greenhouse gases, but a normal heating of the earth is important. So this heating actually generally occurs at high temperature with light winds. So if that area or if that terrain, whatever is there, if it receives high temperature along with light wind, then in that particular area the air mass will be maintained perfectly. What did we mean by air mass? The moisture in that area will be correct, the temperature will be correct and all that. So therefore the weather of the area will be normal. So that is what is about air mass formation. So the area where air masses develop is known as the source area. So air masses can move from one place to another depending on the flow. So air masses over the warm surface develop much faster than the colder surface. So we had heard that earlier, right? So here, because we heard why air masses over the warmer surface develop much faster than the colder surface. Say for example, equator. Equators are warmer because they receive enough amount of sunlight. So therefore, the heating that is taking place there is more when compared to the polar region. Polar region do not receive enough amount of sunlight. Therefore, the heating of the polar region is very, very minimal or negligible. So therefore, for airflow, what is important? This particular absorption of the heat from the sun is very, very important. So that is why those areas which absorb enough amount of heat will have a warmer surface. Therefore, the air mass there will be stable and it will be a continuous stable process. But those surfaces which are colder, there will be a disturbance in the air mass or in the flow of air. Therefore, there will be a disturbance in the stability of the air over the cold surface, or disturbance in the air mass in a cold surface. So when the air masses get shifted, we know that air masses tend to move from one region to another, right? So when air masses get shifted from their source region, that is from where they originated. Say for example, they originated somewhere in the equator, they are shifting towards the temperate region. So when they are shifting from one region to, that is from the source region to one more region, they change over time due to the surface and area over which the air masses flow. So therefore, the shift of the air also decides that which area, because air mass is nothing but hundreds of kilometers, there is flow of air, and that hundreds of kilometers, the temperature remains the same, the moisture content remains the same, and all that, right? So here, when the air mass is moving from one region to another, it will, that is when the air masses get shifted from their source region, from where it originated, they change over time due to the surface and the area over which the air masses flow. So they tend to change when they move from one region to another. So therefore, for air mass formation also, the heating up of the earth is very, very important. So that is why heating up of the earth is needed for the atmospheric circulation as well as for the air mass formation as well. So talking about air mass formation, there are two types of air mass formation. One is warm air masses and the other one is cold air masses. So we had learnt about it previously. So the warm air masses form over the equator or desert areas where solar radiation is maximum. Why? Because for atmospheric circulation, which are the two important factors? One is spinning of the earth and other one is the heating of the earth by the solar radiation that is absorbed by the earth, right? So here, warm air masses are usually seen in the equator. Why in the equator? Because equator is the one that receives maximum amount of sunlight when compared to the temperate regions or the polar region. So that is why. So, or in the desert areas where solar radiation is maximum, and in clear, almost cloudless days, the heat is reflected back to the atmosphere. So here, in regions where there is warmer air masses and if it is not too cloudy, some amount of heat that is there will be re-emitted back into the atmosphere. Therefore, the air will become light and it will flow very, very easily. So in deserts and all that, the flow of air is quite thin, right? It flows easily. Why it flows easily? Why these air masses flow easily? Mainly because warmness of the air, right? Because they receive more amount of sunlight. So as they receive more amount of sunlight there, and also in some cases if the sky is clear, that is if there is no much cloud formation, at that time what happens? Some amount of heat is circulated back to the atmosphere. Therefore, the airflow will get decreased and the airflow will be a stagnant continuous process here. So the air becomes light and it spreads easily to hundreds of kilometers, maintaining the same temperature in that particular hundreds of kilometers and moisture content in that particular hundreds of kilometers. Next, talking about cold air masses. So cold air masses usually form near the poles where solar radiation is at a minimum or negligible. So on cloudless days in the polar regions, the snow cover near the poles, they reflect sunlight away, preventing the earth to warm up. Here already, now you have to understand two differences here. In the warm air masses, what happens? Already enough amount of heat is absorbed by the earth, right? So therefore, during cloudless day, some amount of heat, if it is re-emitted also, it is not a problem. Anyway, the air will be warm itself because little bit of heat is still remaining, right? But that's not the case with regions having cold air masses such as the polar region. Polar region, what happens? They receive very minimal amount of solar radiation. Therefore, the heating is too negligible. The heating of that particular terrain is too negligible, and therefore even cloudy days also they'll not have enough amount of heat to radiate. So whatever heat is there, entirely they get radiated back, even bringing the temperature lower in the polar regions, and therefore preventing that particular polar region from warming up. So that is why melting of the polar ice caps are occurring again because of greenhouse effect itself. So because of human intervention. Otherwise, the polar region will never get heated up, and never ever the melting of the ice caps will occur if it is left to nature and if we human beings do not interfere with nature. So when this persists for a long period of time, cold air masses form over a large area. So what did we understand here? For warm air masses to form, lots of heat energy should be absorbed from the solar radiation which occurs in the equator region, whereas for cold air masses to form, heat energy that is absorbed is very, very minimal. Therefore, cold air masses get formed in these particular region, especially in the polar regions. Next, talking about air mass formation and precipitation, because we had learnt in the previous slides here how the formation of the air, that is, for the formation of the air, what is needed? Heating of the earth is required, right? So when earth gets heated, what happens? Air masses tends to form. So now these air masses, as and when the heating increases, or as and when the earth receives the radiations from the sun, what happens? The surface of the earth gets heated. So when the surface of the earth gets heated, in water bodies, they will start to evaporate. They will evaporate and they will form clouds. These clouds come down as precipitation. Therefore, air mass formation and precipitation both usually goes hand in hand because of this particular reason. So when these two air masses meet, that is, when the cold air mass and the warm air mass meet, moist air is forced upward. So moist air tend to move upward towards the atmosphere, and this causes water vapor to condense. So water vapor, so whatever cloud is formed, that cloud that is formed in the atmosphere, they tend to condense and they will result in a band of heavy precipitation around the globe, which results in rainfall. So here what happens when two air masses, that is when the warm air mass, from where did the warm air mass go? That is from the earth's surface. When warm air mass reaches the atmosphere, it mixes with the cold air mass. Therefore, whatever cloud would have been formed because of the heating of the earth, whatever cloud, or because of evaporation of water from the earth's surface, whatever cloud would have been formed, that cloud will condense and it will come down as rain. So that is nothing but precipitation. So therefore, air mass and precipitation both are interdependent on one another. So let's see what is the definition of precipitation. So precipitation is nothing but the water that falls back to the surface of the earth upon condensing in the atmosphere. So the earth gets heated, or whatever solar radiation is entering into the earth's atmosphere, a part of it will be absorbed by the earth's surface. This causes heating of the land. Therefore, whatever water body is there, from there part of the water will get evaporated. They'll move up and they will form clouds. Now, there is colder air. So, when evaporation is occurring, there is warmer air meeting with the colder air. So, when the warm air mass meets the cold air mass, the cloud that is formed, it will condense and it will come down as rain. That rain is nothing but the precipitation. precipitation. So next, let's see what are the different types of precipitation. So precipitation is mainly of three types. The main one is rain, the other one is fog drip, and the third one is snow. So let's study about these three precipitations of rain. So rain is the most common type of precipitation because throughout the globe it is seen. Snow, we don't find it throughout the globe. So it comprises of little water droplets that turn heavy in the clouds so as to fall onto the surface of the earth. So that is how rain occurs, wherein little heavy droplets are formed which comes down from the clouds and reaches the earth. So amount of rainfall or rain depends on three things, which are the temperature in the clouds, the atmosphere, and the ground level. So all these decides how much amount of rainfall that particular region receives, and this rainfall, this procedure happens in all the seasons. So because formation of the clouds will occur in all the seasons, but rainfall occurs in certain seasons. Next, talking about the fog drip. So fog is a cloud of water vapor. So this cloud of water vapor, it will condense and it will suspend in the air near the earth's surface level. So that is why you see a moisture like, right? You see like a mist like situation there. And this happens because the droplets of water will get, when they become too heavy, they can no longer suspend in the air and they will come down in the form of, or fall down to the ground in the form of fog drip. So here what happens? Fog is nothing but it is a cloud of water vapor only. So this cloud of water vapor, actually it will condense. So when it condenses, what happens? It will form very light heavy drops of water. As and when the heavy drop of water gets even more heavier, the atmosphere cannot hold the water any more longer. So that is the time when they come down in the form of fog. So that is about fog drip. So fog drip is a form of precipitation that originates from the condensation in the atmosphere. So condensation in the atmosphere causes fog drip. The condensation of the clouds in particular causes the rainfall. So this is about fog drip. Next, talking about one more precipitation, that is snow. So snow is one more commonly found type of frozen precipitation, and snow usually we find it in regions. Again, where do we find snow? We find it in regions wherein the cool air mass is more. Wherever there is warm air mass, we find rainfall. Cool air mass will lead to snowing. So here the temperatures which are below freezing from the cloud levels to the ground are advantageous to precipitation in the form of snow. So here also water vapors, they will, when the earth gets heated, the surface water will move to the atmosphere because of heating of the earth and they will form cloud there. Now there what happens if the cool air or the warm air mixes with the cool air, at that time condensation of the clouds will occur wherein it will come down as rainfall. Now if there in that particular atmosphere region, if the cold mass is more or the cold airflow is too much, there what happens, the precipitation, the whenever condensation occurs, those water droplets will get converted into snow and they will come down to the earth's surface as snow. So water vapor which is there, it will turn into ice crystals upon freezing at the cloud level, and therefore it later on it falls on the earth's surface in the form of snowflakes, wherein the ice crystals will get too heavy to stay suspended. So what happens here? When the water droplets is too heavy to stay suspended in the atmosphere, it will come down in the form of fog or mist. When the water droplet is too heavy to stay in the cloud, wherein the temperature is very, very cold, it will come down in the form of snowflakes. So that is the difference. And condensation, when warm air meets the cold air, the condensation of the cloud will occur. Therefore, the water droplets will come down in the form of rain itself, in the form of water droplets itself. So these are the three types of precipitation. So this was about this session wherein we studied about the air mass flow. So entire session is nothing but wherein we learned that for the air mass or the circulation of the air or for the air mass flow, the heating of the earth is actually very, very important. So therefore, heating of the earth and atmospheric circulation, both are interdependent on one another. And atmospheric circulation and also heating of the earth, atmospheric circulation and precipitation are also interdependent on one another, because if heating of the earth occurs, airflow will occur. If airflow occurs, the precipitation will also occur. So that is one. So in the next session, we shall study about the energy resources, wherein we'll learn about the renewable and non-renewable energy resources. And instead of using the non-renewable energy resources which will get depleted over time, what are the alternate energy sources we can depend on, and what are the growing energy needs of the current population, and certain case studies regarding renewable and non-renewable energy resources we shall look into. So we shall take up these topics in the next coming session, which is the last session of this particular unit, that is natural resources, renewable and non-renewable resources. So we shall meet again in the coming session. Thank you.